The Pythagorean Theorem in distance. This is probably one of the most famous theorems of all of geometry. It's the old theorem that if I have a right triangle, and it's really important that it's a right triangle, we need to have that 90-degree angle. The two shorter sides we call the legs of the triangle. And if turns out that if you do the short side squared plus the short side squared, it will equal the hypotenuse or the long side squared. The hypotenuse is always the longest side. If it helps to remember, the hypotenuse is the longest, biggest side of the triangle. That's the only joke you get in today's presentation, hypotenuse. And then the other two sides are the legs. The two short sides go on the left side of the equation, the long side on the right side of the equation. A squared plus b squared equals c squared. So here's an example of how we can use it. We'll notice that the long side here is always across from the right angle. That long side is going to be your c. The other two can be a and b in any order. So when we do a squared plus b squared equals c squared in this case, we just have to plug in what we know. A is 24 squared plus b, that's the x squared, equals c, that's the 26 squared. Order of operations are really important here. We need to simplify the squareds first, and for some of these you're going to want a calculator, and when we get to the end of virtually all of them, you're always going to want the calculator. 24 squared is 576. Plus x squared equals 26 squared, which is 676. So in order to start solving this, we need to get the x alone. We know we can do that by subtracting the 576 from both sides. And that's really nice because it leaves us with x squared equals 100. And we can get rid of that squared with a square root, and that's going to leave behind x equals 10. So that missing side on my triangle must be 10. A squared plus b squared equals c squared. We're going to try and extend this idea of the Pythagorean theorem, though, a bit deeper in two different contexts. The first context is going to be the distance formula. We can actually use the Pythagorean theorem to figure out how long a segment is on the coordinate plane. So if we were to draw in a little triangle around this line, noticing it's a right triangle, we can say we've got a side A and B, and C, the hypotenuse, is going to be the distance of that line segment. What's nice is we can actually figure out what A, B, and C actually are. A, down here at the bottom, that is the distance between x1 and x2. We can actually subtract them. x1 minus x2 will give us the distance from one to the other. Positive or negative, it doesn't really matter because we're going to square it. And b, similarly, is the distance between the y's going up and down. So b is y1 minus y2. So the Pythagorean theorem says a squared, which is x1 minus x2 squared, plus b squared, which is y1 minus y2 squared, equals c squared. And I'm going to actually call c my distance that I want. So we're going to use d for distance, d squared. And normally we don't like to have a squared in our formula for distance, so we're actually going to take the square root of both sides to get our actual distance formula. So the distance of any line is the square root of x1 minus x2 squared plus y1 minus y2 squared. We have a distance formula. Let's see then if we can use that distance formula to find the distance between 2 points. Again, that formula is distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So if we label our points x comma y, where the first point is 1 and the second point is 2, all we have to do is plug this stuff into our distance formula. Distance is the square root of x1, which is -1, minus x2, which is 4, squared, plus y1, which is 3, minus y2, which is -2, squared. And we just have to simplify this formula. Parentheses first. -1 minus 4 is -5 squared, plus, minus a negative means we add, so we actually have a 5 squared. Doing exponents next. -5 squared is 25, plus 5 squared is 25. And so what we really have is the square root of 50. And that we can do really quick on a calculator. The square root of 50 is approximately 7.07 units. So the distance between those 2 points is approximately 7.07 units apart. That's the first use of our distance formula, or of our Pythagorean theorem we're going to do today. The second, we're going to extend the Pythagorean theorem to 3-dimensional shapes. And what's interesting is on a 3-dimensional shape, if I want to go from one corner of a room or one corner of a box to the completely far opposite corner, it's from the front to the back, from the floor to the ceiling, from the left to the right, the completely opposite corner. The Pythagorean theorem actually works just about the same. Now, we have an extra letter to represent the hypotenuse. This time we'll use D to represent the hypotenuse, and A, B, and C to represent the 3 distances. And it turns out the Pythagorean theorem is simply a squared plus b squared plus c squared equals d squared, where d is that hypotenuse, or that long diagonal through the box or through the room. So for example, if I have a box that's 8 by 10 by 12, and I want to see how big of a diagonal I can fit into this, I simply have to say, well, that diagonal, it's the hypotenuse of the room, if you will. So the other sides are A, B, and C. So we plug that in. 8 squared plus 10 squared plus 12 squared equals that distance squared. And just like the Pythagorean theorem, we simplify exponents first. 64 plus 100 plus 144 is equal to d squared. Probably going to use a calculator to make sure I don't do the addition part wrong. So we've got 100 plus 64 plus 144 is 308, is equal to the distance squared. And then I just have to take the square root of 308, and it says the distance is 17.55 inches, is equal to that diagonal distance. So we've done 2 things today with the Pythagorean theorem. We've extended the Pythagorean theorem to 3 dimensions. Works just the same. A squared plus b squared plus c squared is d squared, our new hypotenuse. And we also looked at the distance formula to find the distance between 2 points. So take a look at the homework assignment and see how those go. There's also some basic Pythagorean theorem problems on there, and let your instructor know if you have any questions.